Nighttime webcam footage of glowing south vent, flames visible. USGS live camera feed, dark sky, orange glow pulsing from the crater. Right now, deep inside Halemaʻumaʻu crater at the summit of Kīlauea. Volcano on the big island of Hawaii. Something extraordinary is happening. Look at this. You can see it yourself. That is real. That orange glow, those flames, are burning right now at the south vent of one of the most active volcanoes on the face of the Earth. And what you are watching is a volcano that is charging up, building pressure, filling its magma reservoir, getting ready to explode again. The USGS Hawaiian Volcano Observatory, the scientists who monitor Kīlauea around the clock every single day, have just updated their forecast. Episode 45 of the current eruption is imminent. Their models say it begins between April 21st and April 26th. That means we could be hours away from an 800-foot wall of molten lava shooting straight up into the Hawaiian sky. This is episode 45. Let that number sink in. 45 separate eruption episodes, all since December 23rd, 2024. That is 16 months of Kīlauea refusing to stop. 16 months of lava fountains, ash clouds, molten rock raining down on communities, Pele's hair drifting across highways, and scientists watching in awe, and some concern, as this ancient volcano just keeps going and going and going. Today, on April 20th, 2026, we are going to break down everything that is happening at Kīlauea right now, what the USGS data is actually showing, what a gas piston is and why it matters, what happened during episode 44, and why episode 45 could be different, and what living on the big island of Hawaii actually looks like when your neighbor is an erupting supervolcano. Stay with me. This one is going to be extraordinary. Section 2. What is happening right now at Pregnant 130 5 Woodice? Visuals. USGS tiltmeter graphs, inflation charts, HVO webcam footage, map of Halemaʻumaʻu crater. Let me start with the exact data that the USGS published this week, because every single number here tells part of the story. Since episode 44 ended on April 9th, just 11 days ago, the Wikahuna tiltmeter at Kīlauea's summit has recorded 1 microradians of inflationary tilt. Now, for those of you who are new to volcano science, let me explain what that means in plain language. Imagine the ground beneath the summit of Kīlauea as a balloon. When magma, that is molten rock, pushes up from below into the shallow magma reservoir beneath the crater, the ground swells. It inflates. Scientists measure this swelling using extremely sensitive instruments called tiltmeters. The measurement they use is called microradians. 13.1 microradians of inflationary tilt means the ground has measurably swollen upward as fresh magma floods into the system below. Now, here's the critical comparison. During episode 44, the tiltmeter recorded 6 microradians of deflationary tilt during the eruption itself. That is how much magma drained out when lava fountains blasted up to 800 feet into the air for 5 hours on April 9th. The system is now at 1 microradians of reinflation. It has already refilled 74% of what it released during episode 44, and it is still inflating. The forecast models that USGS scientists use are based on this inflation rate. They track how fast the ground is swelling and project forward, and right now those models are pointing to episode 45 beginning between Tuesday, April 21st and Sunday, April 26th. But there is another signal that is even more dramatic than the tiltmeter data, and you can see it with your own eyes on the USGS webcams right now. The south vent of Halemaʻumaʻu crater is glowing continuously. Overnight, the USGS reported strong and continuous glow with frequent flames at the south vent. And in recent days, faint glow has also been detected returning to the north vent, the first time both vents have shown simultaneous glow since early April 12th. When both vents start glowing, scientists pay very close attention, because that is exactly the pre-eruption signal that preceded multiple previous episodes. And then there's the gas. Right now, even with the eruption paused, Kīlauea is releasing between 1,000 and 5,000 tons of sulfur dioxide gas per day from Halemaʻumaʻu, every day. That sulfur dioxide mixes with moisture and sunlight to form volcanic smog, what locals on the Big Island call VOG. It is drifting across communities right now, and the air quality near the park has been fluctuating between unhealthy for sensitive groups and outright hazardous on multiple days this week. This volcano is not quiet. It is never quiet. It is simply breathing between its screams. Section 3, Understanding Gas Pistons, 5 or 9 hours. Visuals, animation of gas piston cycle, seismogram showing tremor bursts, diagram of vent interior. Now, I want to take a moment to explain something that the USGS has been tracking very carefully over these past few days, because understanding it gives you a real window into what is happening inside this volcano right now. It is called a gas piston, and it is one of the most fascinating, and somewhat terrifying phenomena in all of volcanology. Here's how it works. Deep inside the eruptive vent, magma sits below a layer of volcanic gas. As gas accumulates beneath the lava surface, it builds pressure. Then, like a piston in a car engine, that pressurized gas pushes the lava upward in a surge. When the gas finally bursts through the lava surface, you get a sudden explosive release of gas, a flash of flames visible from kilometers away, and a sharp burst of seismic tremor that shows up on the USGS seismometers. Right now, the USGS is recording these gas piston cycles in both the north and south vents approximately every 5 to 15 minutes. Every 5 to 15 minutes, the ground shakes slightly, gas bursts through the lava surface in the vents, and flames flare up in the darkness above the crater. This has been happening continuously for days. Why does this matter? Because gas piston activity is one of the key precursory signals to a full lava fountaining episode. What scientists have observed across all 44 previous episodes of this eruption is that gas piston activity intensifies, and then, at some point, the system crosses a threshold. The gas pressure becomes too great, the magma level in the vent rises too high, and suddenly, instead of a 5-meter burst of flame, you get a 250-meter column of molten lava blasting into the stratosphere. The USGS says that before episode 45 begins, observers should expect to see lava spattering and overflows from one or both vents as the final precursor signal. That is the last warning before the main show starts. And given the current gas piston frequency and the inflation data, scientists believe that threshold is fast approaching. There is one more complication worth mentioning. On April 18th, USGS recorded a brief deflationary excursion, a temporary reversal where the ground slightly deflated for several hours before returning to inflation late that same night. This kind of wobble is not unusual. It is the volcano system finding its balance, but it did push the forecast window back by about a day, from April the 20th to 25 to April 2026. The underlying trend, however, is unchanged. Inflation is continuing. The glow is intensifying. Episode 45 is coming. Section 4. What happened in episode 44, 9/13/30. The visuals. Footage of episode 44, lava fountaining from April 9th, tephra fall footage, ash cloud, volcano village coverage. To understand what is about to happen, we need to look back at what just happened 11 days ago, episode 44. It began at 9:10 p.m. Hawaiian Standard Time on April 9th, 2026. The USGS volcano notification system went to red. The highest aviation alert level tested within minutes. Lava fountaining started at the north vent of Halemaʻumaʻu crater and rapidly escalated. Within 2 hours, the fountains were reaching 625 feet above the ground. The aviation notice posted by HVO stated, "Fountains currently reaching 625 feet above ground level." NWS reports plume currently reaching 15,000 feet above mean sea level and rising. 15,000 feet. That is the altitude at which commercial aircraft fly. The volcanic plume from a single erupting vent was punching up into airspace that aircraft use. The south vent, meanwhile, did not produce sustained fountaining during episode 44, but it was far from quiet. It displayed periodic gas jetting and intense flame activity throughout the episode. Scientists believe both vents are connected to the same shallow magma reservoir, and the fact that the south vent is now showing stronger pre-eruptive signals than it did before episode 44 suggests that episode 45 may involve more activity from the south vent than the last episode did. Episode 44 lasted 8 hours and 31 minutes before ending at 7:41 p.m. on April 9th. In those 5 hours, the north vent sent tephra, volcanic fragments including ash, pumice, Pele's hair, and larger rock chunks, raining down across communities north of the crater. Tephra pieces as large as 10 inches, the size of a softball, were reported at the Volcano Golf Course subdivision. That is a community where people live, where houses are, where cars were parked in driveways. 10-inch rocks falling from the sky. Fine volcanic ash and Pele's hair, that is the name for glassy volcanic threads spun by the wind from lava, were found as far away as Hilo, 45 kilometers from the summit. Parts of Hawaii Volcanoes National Park and Highway 11 were temporarily closed after the episode for safety. And yet, within hours, they reopened. Because on the big island of Hawaii, this is life. This is what living beside one of the most active volcanoes on Earth actually means. For the scientists at HVO, episode 44 also came with a significant operational challenge. The eruption contributed to a partial outage of HVO's monitoring network. Storm damage from Typhoon Sinlaku, which devastated Saipan last week, also affected Hawaii, and several summit monitoring stations remain offline right now. Scientists are currently working with data from just 2 tiltmeters and a handful of seismometers rather than the full network. They have said they are able to detect any major changes, but they are doing so with reduced visibility. That makes this moment particularly tense. Section 5. 16 months of eruption, the full story, 1330-1830. Visuals, timeline graphic of all 44 episodes, aerial map of lava flow coverage, comparison images of the crater over time. Let us zoom out now and look at the full picture. Because what is happening at Kīlauea right now is not just remarkable, it is historically extraordinary. On December 23, 2024, Kīlauea's summit eruption began inside Halemaʻumaʻu crater. Scientists who had been watching the inflation data knew it was coming. The eruption started, fountains appeared, and the world watched. And then, instead of erupting for a few days and stopping as many had expected, Kīlauea just kept going. 44 episodes in 16 months. Let us put that in context. Kīlauea is one of the world's most continuously active volcanoes. That is well known. But this current eruption cycle, which began in December 2024, is one of the most prolific episodic eruption sequences in the modern monitoring era. The frequency, consistency, and duration of these episodes have given scientists an unprecedented opportunity to study how shallow magma systems charge, discharge, and recharge in near real time. Each of the 44 episodes has had its own personality. Some have been short and sharp, barely 8 hours of fountaining. Some have lasted multiple days. Episode heights have ranged from a few hundred feet to the truly staggering. Earlier episodes in this cycle sent lava fountains to heights exceeding 1,500 feet. Some episodes have involved the north vent only, some the south vent only, some both simultaneously. The pattern is never exactly the same twice, which is part of what makes Kīlauea so scientifically fascinating. Cumulatively, across all 44 episodes, the eruption has deposited significant new lava on the floor of Halemaʻumaʻu crater and the southwest side of the Kīlauea caldera. The crater floor, which already had years of previous eruption lava built up, is being steadily raised. It is as if the earth is slowly filling a bowl with molten rock, one episode at a time. For the communities that live near Kīlauea, in the Volcano, Mountain View, and Hilo areas, this 16-month eruption has become part of daily life in a way that is difficult for outsiders to fully grasp. Air quality alerts arrive on phones like weather notifications. Families plan outdoor activities around VOG forecasts. Children have grown up watching their local volcano erupt more than 44 times in their lifetime. And through all of it, the community has adapted. Because on this island, the volcano does not stop for anyone. The USGS Hawaiian Volcano Observatory has been there for all of it, monitoring every tremor, downloading tilt meter data by hand when the radio network goes offline, flying helicopters over the crater rim to update eruption maps, publishing daily updates at 7 or 8 in the morning so residents know what to expect. The level of scientific dedication required to keep this operation running, particularly during a year that has also seen a partial network outage, storm impacts, and tephra fall closing access roads, is remarkable. And now they are watching the data climb again. Inflation accelerating, gas pistons firing every few minutes, both vents glowing. The 45th episode is coming. Section 6. What to expect from episode 45, 1830-2230. Visuals. USGS eruption prediction graphics, comparison of previous episode starts, webcam footage of approaching eruptive onset. So, what should we actually expect from episode 45? Based on the pattern of the previous 44 episodes and the current pre-eruptive signals, here is what the data suggests. First, onset. The USGS says to watch for lava spattering and overflows from one or both vents in the hours before full fountaining begins. This is the clearest visual warning signal that the main event is imminent. When you see spattering, lava being tossed into the air in small bursts rather than a sustained fountain, that is the vent pressurizing. The timer has started. Second, timing. The current forecast window is April 21st through April 26th. Given that inflation has been ongoing for 11 days and is already at 74% of the pre-episode 44 baseline, many geologists watching the data privately expect the onset to fall in the earlier part of that window, possibly as soon as Tuesday or Wednesday. But volcanoes are notoriously unpredictable, and the brief deflation event on April 18th is a reminder that the system does not always follow a straight line. Third, intensity. This is where it gets interesting. Going into episode 44, the south vent showed minimal pre-eruptive activity and ultimately did not produce sustained fountaining. Going into episode 45, the south vent has been showing continuous, intense glow and frequent flames, a much stronger pre-eruptive signal than before episode 44. This suggests that episode 45 could see active fountaining from both vents simultaneously, which would be a more dramatic and powerful eruption than episode 44. Fourth, tephra hazard. The direction and intensity of tephra fall during any episode is determined by two factors: fountain height and wind direction. USGS has noted that in recent days, winds near the vents have been coming from the northeast in the mornings, before turning more variable in the afternoons and evenings. Depending on when episode 45 begins and how winds are blowing at that moment, tephra could fall in different directions than it did during episode 44. Communities to the south and west of the summit could potentially be affected if winds shift. The USGS will issue real-time aviation color code alerts the moment fountaining begins. Watch for the code to jump to red. Fifth, duration. Most episodes in this cycle have lasted less than 24 hours, with some as short as 8 hours. A small number have lasted multiple days. There is no reliable way to predict in advance which kind episode 45 will be. Once fountaining begins, the USGS watches tilt meter deflation rates closely. When the deflation rate slows and stops, the eruption is ending. Before we close out, I want to answer the question that I know many of you have been thinking throughout this video. Why? Why does Kīlauea keep erupting? Why won't it stop? What is actually driving 44, soon to be 45, eruptions in 16 months? The answer lies thousands of kilometers below the surface of the Earth, in a structure called a mantle plume, or more commonly, a hotspot. The Hawaiian Islands were not formed by tectonic plate collisions the way most volcanic regions are. There are no two plates grinding against each other beneath Hawaii. Instead, there's a fixed point of extraordinary heat deep in the Earth's mantle, a hotspot, where superheated rock rises in a column from deep in the mantle toward the surface. As the Pacific Plate moves northwest over this hotspot at approximately 7 centimeters per year, the hotspot burns a new volcano through the crust. The Hawaiian island chain itself is essentially a trail of extinct volcanoes left behind as the plate moved, each one older than the last as you travel northwest. The big island, Hawaii, is sitting directly over the hotspot right now, which means the magma supply feeding Kīlauea is essentially endless on any human timescale. There is no shortage of material. The hotspot keeps pushing molten rock up. Kīlauea's shallow magma reservoir keeps filling, and when the pressure gets high enough, it erupts, drains, refills, erupts again. This cycle has been happening for hundreds of thousands of years. It will continue for hundreds of thousands more. The 44 episodes since December 2024 are just a single breath in the lifespan of this volcano. What makes the current eruption cycle scientifically remarkable is not that Kīlauea is erupting. That is expected. What is remarkable is the episodic nature of the current cycle. Rather than a continuous effuse of eruption, where lava quietly flows from the vent for months or years, Kīlauea is doing something more like a heartbeat. Charge, beat, rest, charge, beat, rest. Each beat is an explosive lava fountaining episode. Each rest is a pressurization phase like the one happening right now. Scientists are using this episodic cycle to learn things about shallow magma systems that are very difficult to study anywhere else in the world. The way inflation builds before each episode. The way deflation tracks during each episode. The way the vents alternate between activity. All of this data is generating scientific papers and insights that will help volcanologists better understand, and eventually better predict, eruptions at volcanoes around the world. And for those of us who are simply watching, who are captivated by the raw power of the Earth doing what the Earth does, it is one of the greatest natural spectacles of our lifetime. Section 8, Closing, Call to Action for 26.28 hours. Visuals. Slow nighttime footage of glowing vents, flames, dark sky, lava glow reflected in crater. So here is where we are on April 20th, 2026. Kīlauea's summit is glowing tonight. Both vents are active. The tilt meters show the ground swelling with fresh magma. Gas pistons are firing every few minutes inside the crater. The sulfur dioxide is rising. And the USGS has told us clearly episode 45 is coming sometime between now and April 26th, the 45th time this volcano has erupted since December 2024. This is not a warning sign that something is going wrong. This is not a cause for panic. This is Kīlauea doing what Kīlauea does, and doing it with a consistency and power that is humbling to witness. But it is also a reminder that the earth beneath our feet is alive, that the ground we build our cities on, drive our cars across, and call home is the thin skin of a planet that is constantly moving, constantly churning, constantly reshaping itself. Kīlauea is not an anomaly. It is the earth being honest about what it is. We are going to keep tracking episode 45 in real time right here on this channel. The moment USGS issues a red aviation alert, the moment fountaining begins, we will be here with updates, footage, and breakdown. So make sure you have subscribed and hit that notification bell so you don't miss a single update. And if you want to watch the USGS live webcam yourself right now, and honestly, you should because that glow is something to see, the link is in the description below. This is our Earth, and right now she's waking up again. We will see you when episode 45 begins. Video production notes, recommended B-roll sources, all free public, USGS HVO live webcams, USGS. Volcanoes, Kīlauea, summit webcams, USGS, YouTube live streams, YouTube, com.usgs streams USGS. Episode 44 footage archive. USGS, Gov, at Volcanoes, Kīlauea, Science, Eruption. Information, USGS, tiltmeter graphs, publicly available at HVO website. Key facts to display as on-screen text. Episode 45. Forecast window, April 21-26, 2026. Current inflation, 13, 1 microradians, UWD tiltmeter. Episode 44. Deflation, 17, 6 microradians. Duration, 8, 5 hours. Peak height, 800 feet. SO2 emissions during pause, 1,000 to 5,000 tons day eruption start date. December 23rd, 2024. Total episodes, 44 completed, 45 incoming, 0 miserios. It's glowing right now, 130. What USGS is actually saying. Gas pistons explained. What happened in episode 44? 1330, 16 months of eruption. 1830, what to expect from episode 45. 2230, why Kīlauea never stops. 26, watch live. Plus, subscribe sources, USGS Hawaiian Volcano Observatory daily updates, April 14th, 2026, USGS Volcano. Notice DOI USGS HVO 2026 4 18T 75906 USGS Volcano. Notice DOI USGS HVO 2026 4 17T 1640 Big Island. Video news, Biggest Land Video News.com, April 14th and 19 updates. Hawaii Volcano Expeditions Lava Update, April 15th, 2026.